everyone, this is Miss Mancini, and in today's video we will be continuing those properties of logarithms. Just as a reminder, as always, make sure you're writing down questions as you go. Okay, it's important that you do this because tomorrow is a very long way away, and I wouldn't want anyone to forget what they were thinking while watching this video. Our goal for today is to condense these logarithm expressions. So yesterday, or in the last video, we worked on expanding them. Today we'll be going backwards. And eventually we'll also get to the change of base formula. But for now, let's work on condensing these logarithm expressions. And like I said, that's pretty much going backwards from the last video. So we do need to remember some things we learned before. One example, in the last video, say you had log of 3, or log base 3, of 7 squared. You would have taken this exponent and put it out front in front of the log here. In this example, we're going to be going backwards, and we want to write it as something that looks like this. So anytime you have a number out front, you can write that as the exponent here. Same thing with this number here. So I'm going to rewrite this as log base 3 of 7 squared. And going backwards to get it to look like that. And this would be minus log base 3 of x to the 5th. Next thing we need to think about is what happens if you have the same base and you're subtracting. Okay, these are both log base 3, so we can do something with that. And remember, when you subtract, you're actually dividing this argument here. So this can become log base 3, since they're both log base 3, of 7 squared over x to the 5th. Our last step always is to make sure our answer is as simplified as possible, and we all know that 7 squared is the same as 49, so I'm just going to go ahead and rewrite that here. That is how you condense the expression, or go backwards from what we did in the last video. Let's try some more examples. Okay, example B. We have the log of 6 plus 2 log of 2 minus log of 3. Just a reminder, if there's no base written in here, that means it's automatically base 10. First thing I always look for in condensing these logarithmic expressions is there a number out in front that I can change to be an exponent, just like we did in example A. So I'm going to go ahead and do that first. Log of 6 is going to stay the same since there's no number in front. This 2 is going to become the exponent of our 2 here. This becomes plus log 2 to the 2nd power. And our log of 3, or minus log of 3, will stay the same. I'm going to simplify this as we go and just make this 2 squared 4. This makes it a little cleaner. And I just like things to be simple. This becomes log of 4 minus log of 3. Okay, now we have to deal with these plus and minus signs. Again, since they don't have a base here, they're all base 10, so they all have the same base. So we can think about what we did in the first video when we were expanding these. Okay, so when you have addition sign, that really means you're going to be multiplying these numbers here. So we can rewrite this as the log of 6 times 4. And I'm going to take this one step at a time, working from the left all the way to the right. So I'm just going to rewrite that minus log of 3. And now that we dealt with the addition sign, we still have to deal with the subtraction sign. So anytime you have a log and subtraction, you're actually dividing those arguments. Oops, I just meant to underline the 3. You're dividing those arguments there. Okay, so this is the same as log of 6 times 4 divided by 3. Okay, this minus log 3 changes in division. And our last step is to just make sure it's as simplified as possible. So we all know that 6 times 4 gives us 24, and 24 divided by 3 will give us a grand total of log of 8. It's our final answer. Okay, so by going through this whole condensing process, we can say that this entire expression here is the same as log of 8. Kind of cool, right? Great. Let's make some more cool things happen in letter C. Okay, but before I share some of my work with you on C, I want you to try some things on your own, mainly doing the first steps that we've been doing, where you rewrite the number in front as the exponent. Okay, so try that on your own, make sure you know what you're doing, and I will come back with the work. Okay, if you followed my instructions, as I hope you did, so you're testing yourself, you should have gotten log base 8 of x squared minus log base 8 of 5, which didn't change, minus log base 8 of y to the third. Pretty simple, just changing that number out in front to our exponent. Okay, so from here, you need to deal with that subtraction sign. So we're trying to make it all written as one log. Okay, so you have one subtraction sign here you're going to have to deal with, and another you'll deal with after we deal with the first one. Okay, so I'm going to pause again, because this example, I want you guys to try some things, and I just want you to rewrite this first part here. Okay, so I'm going to pause and come back with the answer rewritten. Okay, back with the answer. I hope you did it on your own, not cheating the system. Should have gotten log base 8 of x squared divided by 5. Okay, you're just dividing when you see subtraction. And we still have that we're subtracting log base 8 of y to the third. I just like to take it one step at a time. Okay, so again, we see subtraction sign. We know we're going to have to divide these arguments here. Okay, so if I rewrite that, since they're both log base 8, I'm just going to make it 1 log base of 8. And we have x squared divided by 5. We need to divide by this here. So divided by y to the third. The reason we're doing this example is sometimes something like this will show up and it looks really yucky and you might want to quit. But we're not going to do that because we're going to try one together and you'll be able to do them forever and ever. So let's just work with this part right here off to the side and simplify that fraction up, and then we can rewrite it back into the logs. Okay, so this really says we're taking x squared divided by 5, and the subtraction sign here means we're dividing that all by y to the third. Okay, really, if you're dividing, it's the same thing as multiplying by a fraction. So we can change this division sign to a multiplication sign, and that's like saying I want to take x squared divided by 5 and multiply that by the fraction 1 over y to the third. Okay, and if you rewrite that, actually I'm kind of running out of room, so I'm just going to come back to my log problem over here. And you can really rewrite that as log base 8 of x squared over 5y to the third. Remember, a little fraction review. When you multiply fractions, you multiply across the top and you multiply across the bottom. So that's where I got that from. Okay, and that is as simplified or condensed as that log can get. Okay, there's no simplifying you can do. If there was, you should do that. Last example of condensing. If you haven't understood anything I'm saying up to this point, which I hope isn't the case, please start the video over, rewatch it, write down more questions, and come back with stuff to ask your teacher if you're still lost. Okay, but in example D, we have some natural logs, which doesn't mean everything we just learned changes. It just means that we have a special kind of log. Okay, so first thing you should always look for is these numbers out front here. And remember that those become exponents. So this is really like the natural log of x to the third plus the natural log of y to the fifth. Okay, in this example, it's super easy. We just want to introduce the natural log here. Anytime you're adding, remember that you're multiplying these arguments here, okay, those variables. So in this case, it will all become the natural log of x to the third times y to the fifth. And that's as far as you can go. Super easy, but again, the rules don't change just because it's a natural log. So that's all the examples we have for condensing logs. The last thing we need to talk about is just the change of base formula. Now this formula looks kind of complicated because there's a lot of logs and a lot of variables. So listen carefully to what I'm going to say, and it's really not that hard once you think about it. Okay, so it says let u, b, and c be positive numbers. So you can plug in any positive number to u, b, and c in this formula. But b and c can't be 1. Then you can take the log c of u, so the base is c, and change that into log base b of u divided by log base b of c. Okay, in other words, we're changing the base. So instead of our base being c, we're going to change it to a base b. But in order to actually be able to change that base, we have to use this formula. Okay, notice these letters here come from our original problem. And the reason we use this formula is so we can plug logs into our calculator. Because right now, if you just wanted to take log 3 of 7, you can't actually plug a base of 3 in your calculator. Okay, what our calculator can calculate is just our standard log base, which is base of 10. So our calculator, anytime you type in log, is automatically assuming that the base is 10. So if it was like log base 10 of 7, in your calculator, all you have to plug in is log of 7, because that button automatically assumes this base is 7. Okay, I know there's a lot of scribbling going on here. So let me explain how you would actually change this red formula here. Okay, so this is our original problem, and in order to change that, you'd have to take a new base, which we always assume is just the log, base 10, which we just read as log, and we plug in u on top. So from our original problem, u would be 7. And then you divide that by log of our original base, or c, which was 3. Okay, now that we got that, our last step would be to figure out what this is as a number. Okay, so to plug it into our calculator. So I just want to go through that before we end this video. Just a reminder, our log button is right here under the x squared. So we're going to take the log of 7 and divide it by log of 3. Okay, since we're dividing it, I want to make sure I put it in parentheses so my calculator does the correct order of operations. So we're taking the log of 7 and we're dividing it by, in parentheses again, the log of 3. Okay, so when you type in your calculator, it should look exactly like this, unless maybe you have a different version of the calculator, but something very similar. Okay, so plugging that in, we get this value is 1.77. Okay, so if ever you need to get a decimal answer or you need to plug in a log to your calculator, you always want to go to this button here. So just write that on your note sheet, 1.77, we'll round to the hundredth place, and that is your decimal answer. So that's all I have for today's video. Just make sure you write your key points so you can come to class knowing what the main ideas were, so we can have a nice discussion about what went on in this video. As always, I hope you wrote down questions. Make sure you ask your teacher when you go to class what those questions were. And have a good night.